Hello everyone. So in this video we are going to see what is half subtractor and how to implement it on Tinkercad. So basically in half subtractor we subtract two bits. So let's see the truth table. So here we have two inputs A and B and two outputs. One is difference and one is borrow. So uh, let's see the first input 0 and 0. So when we subtract 0 from 0, the difference is 0 and borrow is also 0. When we subtract 0 from 1, so we cannot directly subtract 1 from 0, so we need to borrow one bit from the next bit. So borrow becomes 1 and 1 0, that is 2 minus 1 becomes 1. So borrow is also 1 and difference is also 1. Then 1 minus 0, so we did not borrow any bit, so borrow is 0 and 1 minus 0 gives us difference as 0. Then 1 minus 1, so again we did not borrow any bit, so borrow remains 0 and 1 minus 1 gives us difference as 0. So if you take a closer look at the difference, your difference represents the XOR gate, and borrow is only high when A is 0 and B is 1. So let us see the K map. We can simply plot the K map, and for difference we have plotted the K map. So we get D as A XOR B and we get the borrow as A bar into B, as only A as 0 and B is equal to 1 gives us high output for borrow. So looking at this, now we can make the logic diagram. So simply there are two inputs A and B, and difference is basically XOR. So here we have the XOR gate. So A and B are the two inputs, and A XOR B gives us the result as difference. And then here we have a AND gate, and here is a NOT gate. So A goes here, becomes NOT. So here it is A bar dot B, which gives us A bar into B, which is our borrow. So now we can plot this into the Tinkercad simulation platform. So let's start. First of all, we need some components such as breadboard. So we use a breadboard. Then we require power supply. So we type here power supply in the search bar and we take the power supply. Then we need a switch to give different inputs. Then we require one XOR gate. So here is our XOR gate, we place it here. Then we need one AND gate, so we type here AND and we take the quad AND gate, we place it here. And remember, we also need a NOT gate, so here we need to type inverter. Mind it, if you type here NOT, you will get nothing, so you cannot type NOT here to find NOT gate. No, so we type here inverter, which gives us hex inverter, which is nothing but our NOT gate. So we place it here. We have taken our ICs. Now we need two outputs to be represented, so we take two LEDs, one red, and we can also change the color here. We can give any color, you can give it the color you want. And yes, we also need two resistors because the LEDs won't be able to handle such high voltage. So two resistors. Resistance, we will keep it here 330 ohms, and here also 330 ohms. We connect here with the cathode and yes, that's it. Now we give the positive supply here in the breadboard. We also give the negative supply here. We can connect the resistor here and give it here. Again, for the second LED, we give the negative supply here to the cathode. To the anode, we will connect the output of our difference and borrow. And now for this half subtractor, we are using only two inputs, so we need only two switches. So we will give power to only two of the switches, 1 and 2. We can rearrange the wires to make the circuit look neat. Now for every ICs we need to give them power, so we connect the power to positive terminal so the ICs work properly. And we also need to ground the 7th pin. This is the 7th pin and this is the 14th pin of the IC, so we need to ground all of them here. See, all these green circles represent the same points, so even if I connect this point to negative terminal or this point, it means one and the same. Similarly here, all these green circles represent the same point, so negative terminal is connected with this point, it means all these points are connected to the negative terminal. Now basically our ICs are ready. Now we need to make our connections. So first of all, XOR gate has two inputs A and B, and the output is directly our difference. So here we have the XOR gate, you can see the name appearing here, and two inputs, input 1A and input 1B. So we take one input from here and one input from 2 and give it here. So the two inputs 1A and 1B are connected to the two switches, and the output is available here at the third pin, which is called output 1. So we take a wire from here and connect it to the first LED at anode. So now this LED will behave as the difference, because here XOR gate gives us the difference. So we can also name it here that this is our difference. And secondly, the other will act as borrow, so we can also name it as borrow. So for neatness, you can also name this part as half subtractor. It is not necessary, but it looks good, so we name it here half subtractor. Now for the second part, for the borrow part, what we do is we give one input here, one input to the AND gate, and one other input we are taking the NOT of the other input. So first of all, we can also take input directly from the switch, or we can take it from here also, because all these points are same, all these points are connected to the input 1. So we can also directly take this point and connect it to our input 1, or we can also take it from here, input 1A. Now for the second input, we are taking it from the NOT 1. This is our NOT gate, hex inverter. So we take input 2 and give it to the input of our NOT gate, and the output of our NOT gate is present here. So we take the output of NOT gate and give it to the input 1B of the AND gate. So now for this AND gate, one input is directly our input 1, and this is, and here we have the NOT of the other input. So here we made one mistake, and this I did it purposely because we have taken not of the second input, and here we need to take the input of not of the first input. So here it was a mistake done purposely, so we can change it. Now the input 1a comes from the second input 1b, and the second input 1b must be not of our input 1. So we connect it here, and now our AND gate is ready. It has one input as a bar, which is not gate here, which comes from here input 1, and the second input is B, which comes from input 1b of the XOR gate. We now have the output 1a ready at the AND gate, and we connect it to the borrow. So now it looks good, and this circuit should work. If there is an error, this won't work and we would resolve the error. So let's start the simulation. So for 0 0, our difference and borrow both are 0. We can verify the truth table now. So for next 0 and 1, the borrow should be 1 and the difference also should be 1. So for 0 and 1, both LEDs are glowing, so difference is also 1 and borrow is also 1, so this input is also verified. Then 1 0, 2 becomes 0 and 1 becomes 1, so the difference is 1 and borrow is 0, and difference is 1 and borrow is 0. So again it is correct, and for the last input 1 and 1, both borrow and difference become 0. So let's check it. So yes, both borrow and difference become 0. So this is our half subtractor, and this is what it looks like. Simply we took the breadboard, we took the switch, we took power supply, 3 ICs, XOR gate, AND gate and NOT gate, hex inverter in Tinkercad, then 2 LEDs, 2 resistors, one was difference and one was borrow. We made it according to the logic diagram, which we derived from the K map, which we derived from the truth table of half subtractor, and this is what it looks like. So now we can stop the simulation, and finally this is what half subtractor is. Thank you for watching this video. Please share, subscribe, like and comment.